and click or a straight connection, fiber connection defined for fiber distributed data interface or FDDI, and also a 10 base FX network. Actually, we can use MIC, ST or SC connectors. Because of that, now we know about different categories of the fast Ethernet: 100 base X and 100 base T4. 100 base X include 100 base TX over the copper cable and 100 base FX over the fiber optic cable. But let me to emphasize that the most implemented cable between these three categories are the 100 base TX. Today's maybe we use higher speed, but in the days that we used fast Ethernet, 100 base TX with RJ45 connector was the most implemented category of fast Ethernet. Alright, now let me to explain the collision delay in Ethernet and also in the fast Ethernet. You know that in Ethernet means 10 base T, we use 10 megabit per second of the, for example, data rate, and it means that in 1 bit, okay, can be sent in the, for example, 0.1 microsecond. Let me to explain it. Look at here. When you say I'm using the 10 megabit per second, it means that we can send 10 megabit, okay, on only 1 second. Actually, we can send 10 megabit in 1 second. Because of that, we understand that here in for 1 bit we need only 0.1 microsecond. It is obvious, okay? And also in the fast Ethernet, in the 100 base T or TX, for example, it means that we have 100 megabit per second of data rate. What does it mean? It means that we can send 100 megabit in 1 second. And because of that, 1 bit can be sent in 0.01 microsecond. It is obvious, okay? After that, you know that when we send the traffic from a PC over the media, we should ensure that here we don't have a collision. How we can understand we don't have collision? When you send data over the media, okay, you should, for example, take some feedback from the line. If the sending traffic and receiving traffic are same, it means that we don't have collision, okay? You know that the minimum size of the Ethernet frame is 64 bytes. 64 byte equal to the 512 bit. What does it mean? It means that because in fast Ethernet for 1 bit we need only 0.01 microsecond time to send, okay? For 512 bit, okay, we need 5.12 microsecond. Look at here, 0.01 microsecond for 1 bit. For 512 bit we need 5.12 microsecond. But in Ethernet, okay, for the 512 bit we need more time. Actually, the collision delay or the time that takes that we discover the collision, okay, in the fast Ethernet is 5 microsecond, okay, about 5 microsecond, but in the Ethernet means 10 megabit per second Ethernet is the, for example, 51 microsecond. The overriding design rule for 100 megabit per second Ethernet network is that the round trip collision delay must not exceed for example this time. It is so important. Alright, now let me to introduce Gigabit Ethernet or IEEE 802.3z or IEEE 802.3ab. Let me to explain it. You know that Gigabit Ethernet or GBE or 1 gig, okay, is the term applied to transmitting Ethernet frame at a rate of a gigabit per second. Okay, Gigabit Ethernet, a transmission technology based on the Ethernet frame format and protocol used in local area networks or LANs, provides a data rate of 1 billion bits per second or 1 gigabit. Okay, Gigabit Ethernet is defined in the Institute of Electrical and Electronics Engineer or IEEE 802.3 standard and is currently being used as the backbone in many enterprise networks. The initial standard for Gigabit Ethernet was produced by the IEEE in June June 1998 as IEEE 802.3z and required optical fiber. Actually, in 802.3z, we need to use optical fiber and also coaxial cable. Okay, 802.3z is commonly referred to as 1000 base X, where X refers to either CX, SX, LX, or non-standard ZX. Here you can see 1000 base CX, 1000 base LX, 1000 base SX, but we have non-standard version 1000 base ZX. Okay, and then IEEE 802.3ab, ratified in 1999, defines Gigabit Ethernet transmission over unshielded twisted pair or UTP category 5E or 6 cabling and became known as 1000 base T, as you can see here. Okay, with the ratification of IEEE 802.3ab, Gigabit Ethernet became the desktop technology, as organization could use their existing copper cabling infrastructure. The IEEE 802.3z standard specified the operation of Gigabit Ethernet over fiber and coaxial cable and introduced the Gigabit Media Independent Interface, or a GMII. Okay, what is the GMII? Let me to explain it a little more. The media independent interface was originally defined as a standard interface to connect a fast Ethernet, okay, MAC layer, MAC block to a physical chip. But here in the Gigabit Ethernet, the Gigabit Media Independent Interface is standardized by IEEE 802.3u and connects different type of physical layers to MACs. Being media independent means that different types of physical devices for connecting to different media, twisted pair, fiber optic, and etc., can be used without redesigning or replacing the MAC hardware. Thus, any MAC can be used with any physical, independent of the network signal transmission media. This is beyond the scope of our course, but here, as you can see now, we know about the different versions of the Gigabit Ethernet. IEEE 802.3z in 1998 released, and IEEE 802.3ab in 1999 was released. Okay, the difference is that in the IEEE 802.3z we use fiber optic and also the coaxial cable, in most cases fiber optic. But in IEEE 802.3ab we use the twisted pair cable actually. And here we can see about the IEEE 802.3z, we have three versions: 1000 base 6, 1000 base LX, 1000 base SX. I will explain a little more about them. And after that, about the 1000 base T, we have the for example 1000 base T, and this is the IEEE 802.3ab. Now let me to explain a little more about the 1000 base 6, 1000 base LX, and 1000 base SX, and after that 1000 base T. First, let me to explain 1000 base 6 Gigabit Ethernet over a coaxial cable. 1000 base 6 is a type of standard for implementing Gigabit Ethernet networks. The 6 in 1000 base 6 stands for short haul copper, and it indicates that this version of Gigabit Ethernet is intended for short cable runs over copper cabling. 1000 base 6 technologies are in the beginning stage of being widely implemented in enterprise level network and are primarily used for collapsed backbone and high-speed interconnects within wiring closets and equipment rooms. Actually, 1000 base 6 is an extension of standard Ethernet technologies to gigabit level network speeds. 1000 base 6 is normally implemented using shielded twisted pair or STP cabling or some type of coaxial cabling. Cable segment have a maximum length of only 25 meter, okay? 1000 base 6 employs 8B, 10B coding with serial transmission rate of 1.25 gigabit per second. STP cabling is a standard 150 ohm balanced cabling and should have a quality slightly better than the, for example, IBM Type 1 cabling. 1000 base 6 is intended mainly for connecting high speed, hubs, Ethernet switches, and routers together in wiring closets. Common implementation for 1000-base are in switch-to-switch and switch-to-server connections, with switch-to-server connections being the most frequently